Okay, today we're doing a little review of our right triangle trigonometry that you learned back in geometry. So, trigonometry, what is it? Trigonometry simply means it is the study of triangles, TRI being 3. The 3 trig functions that you learned in geometry were sine, cosine, and tangent, and those were abbreviated SIN, pronounced sine, not sin, COS for cosine, and TAN for tangent. Now, sine, cosine, and tangent are the ratios of the sides of triangles. And you may have used SOHCAHTOA to memorize those trig functions, where sine of theta, this symbol right here is the Greek letter theta. It's like an O with a line through the middle of it. Sine of theta is the opposite side over the opposite side over the hypotenuse. Cosine of theta is the adjacent side over the hypotenuse. Tangent of theta is the opposite side over the adjacent side. Now those were the only 3 that you did back in geometry, but we're going to be adding 3 more to that list. And the other 3 trig ratios are called secant, cosecant, and cotangent. And those are abbreviated CSC for cosecant, SEC for secant, and COT for cotangent. And all these is they are the reciprocals of cosine, sine, and tangent. Cosecant, if you'll notice, the ratio is hypotenuse over opposite. So it is the reciprocal of sine. Secant of theta is hypotenuse over adjacent, which means it is the reciprocal of cosine. And cotangent of theta is adjacent over opposite, which is just the reciprocal of tangent. And theta is the acute, or one of the acute angles in your right triangle. Now there are some Greek letters that are commonly used to represent angle measurements in trigonometry. One of those that is used here is the Greek letter theta. Another one is beta. Another one is alpha and gamma. Those are commonly used to represent angle measurements. Alright, let's take a look at some of what we're going to be doing now in terms of some of the problems in this section. So on this first problem, what we want to do is find the 6 trig ratios for this following triangle. Alright, so if you know 2 sides of a right triangle, you can find the missing side, and I'll just call this C since it is the hypotenuse, by using the Pythagorean theorem. So you would have 4 squared plus 9 squared equals C squared. So 36 plus 81 equals C squared. Adding these together, you get 117. And so therefore C is equal to the square root of 117. We're just going to leave it in this form because this is an exact value, as opposed to a decimal, which is not an exact value for C. Alright, so sine, if you remember from the other page, is opposite over hypotenuse. So it's all in reference to this angle theta that we're referencing. So the opposite side is 4, and the hypotenuse is C, which was square root of 117. So you're going to have 4 over square root of 117. Now cosine is adjacent over hypotenuse. Now the adjacent means the leg of the triangle that is right next to the angle. So that would be 9. So 9 is the adjacent, there's your hypotenuse, so it's going to be 9 over square root of 117. And tangent is opposite over adjacent, 4 over 9. Now cosecant, if you'll remember, was the reciprocal of sine. Sorry. Cosecant was the reciprocal of sine, so cosecant is square root of 117 over 4. Secant was the reciprocal of cosine, which is square root of 117 over 9. And cotangent is the reciprocal of tangent, which would make it 9 over 4. Alright, so example 2, we're going to get into finding the lengths of some of the sides of a triangle. Now before we go into any of the problems, one of the first things you want to do is check your calculator. Your calculator must be set on degrees for these particular problems. To set your calculator to degrees, if you will move your cursor up to this icon that is next to, or that's the battery, and it says angle RAD. That means it is measuring in radians. That is not what we want. So to change it, click on the home button, go to number 5, settings, and number 2, document settings. Tab to where it says angle, press the right arrow, go down to degree, and click on that. Now tab down until you get to OK, and select it. Now let's go back to our document, and we're in radians. And you can go up to the battery and check if you want. Alright, so with that done, this says use the trig ratios to find the length of the missing sides of this triangle. So this is the angle that we are referencing. Now, let's say that we're going to find x first. We need to use the side that we're trying to find and a side that we know the measurement for, which is this one. Now in reference to this angle, x is the opposite side, 2 is the adjacent side. The trig function that uses opposite and adjacent is the tangent function. So we write this out as the tangent of the angle is equal to the opposite side over the adjacent side. Now to solve for x, you would simply multiply the 2 over to the other side, and 2 times the tangent of 49 is what we'll get. So all we do is press 2, come over here to where it says trig, and we'll select tangent of 49, and that is equal to 2.3. So therefore x is equal to 2.3. Now to find y. Y represents the hypotenuse. So we're still going to use the 2, which is the adjacent. Now hypotenuse and adjacent uses the trig function cosine. So we would write this out as cosine of 49 degrees is equal to adjacent over hypotenuse. Well, we need to get the variable out of the denominator, so you multiply it to the other side, which would make this y times the cosine of 49 degrees equals 2. Now we need to get y by itself, so we're going to divide by cosine of 49. So 2 divided by cosine 49. And if you type that into your calculator, you're going to end up with 3.0. Alright, question 3. Use the trig ratios to find the length of the missing sides. Right. So once again, I'm going to find x first, and x represents the opposite, and then the side that's given to us is the hypotenuse. So opposite and hypotenuse is the trig function sine. So we write this out as sine of the angle equals the opposite side over the hypotenuse. Multiply the 8 to the other side, so you get 8 times the sine of 36, and 8 times the sine of 36 is 4.7. So now to find y, 8's still the hypotenuse, but y is the adjacent side. Adjacent and hypotenuse. That trig function is cosine. So we write this out as cosine of 36 is equal to the adjacent over hypotenuse. We just need to multiply the 8 to the other side, so you have 8 times the cosine of 36, and that comes out to 6.5. Alright, and an application problem here. A 20-foot ladder is leaning against a wall, forming a 70-degree angle with the ground. How far is the base of the ladder from the wall? So let's just draw a picture representing what we are referring to here. And there's our wall. Now I've got a ladder leaning against that wall right here, and it says it is a 20-foot ladder, so the length of this side is 20 feet, and it forms a 70-degree angle with the ground, so that angle right here is 70 degrees. How far is the base from the wall? That would be this side right here. So we want to find the length of this. Well, what trig function is this? This side is the adjacent side. This side is the hypotenuse. Adjacent and hypotenuse. That is cosine. And the angle that we're using is 70 degrees. So adjacent over hypotenuse. Solving will give you 20 times the cosine of 70. And 20 times the cosine of 70 is 6.8, and this measurement is measured in feet. Alright, now in the previous problems we were using the trig functions to find the length of sides of a triangle. We can also use our trig functions to find the measures of the angles of a triangle. So let's see how this works here. All right, we're going to find x first. Now, x, we want to look at what sides are given to us. The 6 is the side opposite this angle. 15 is the side adjacent to this angle. So opposite and adjacent is the tangent function. So tangent of the angle, which is x, equals 6 over 15. Now we need a way to get the tangent portion of this function over to the other side. And the way that we move this over is by doing the inverse, which means x will equal tangent inverse, and that's the notation for inverse, of 6 over 15. Now if you press the trig button on your calculator, you're going to see an option that says tangent inverse. So that's the one you're going to select. And you just type this in as you see it, and x is going to come out to equal 21.8 degrees. Now, to find y. Y is referencing this angle. So now 15 represents the opposite side because it's opposite the y value. 15 is the opposite, 6 is the adjacent. Still using tangent function, but now its tangent of y equals 15 over 6 instead of 6 over 15. Got to separate this tangent portion of our function. By moving it to the other side, it becomes tangent inverse of 15 over 6. And once again, when you put that into your calculator, you're going to come out with 68.2 degrees. Now, if you remember, this angle is 90 degrees on this triangle. And the angles of a triangle have to add up to 180. Well, if this one's 90, it means angles x and y should add up to 90 also. Because 90 and 90 would add up to 180. Well, x was 21.8 degrees. Y was 68.2 degrees. That does add up to 90 degrees. So that's one way that you can check your work. Alright, question number 6. Find the measures of the acute angles of this right triangle. Alright, so once again I'm going to start with x. The sides given to us, this one is adjacent to this angle. This is your hypotenuse. Adjacent and hypotenuse is the trig function cosine. So we say cosine of the angle equals 11 over 15. That's the adjacent over hypotenuse. Got to move the cosine portion to the other side so we can get the x by itself. So that becomes inverse of 11 over 15. And when you put this in, you're going to end up with x is equal to 42.8 degrees. Now to find y. So y, 15 is still the hypotenuse, but the 11 this time is going to represent the opposite side. So now you have opposite and hypotenuse, which is sine. So we write this out as sine of y equals 11 over 15. Y will equal the sine inverse of 11 over 15, which comes out to equal 47.2 degrees. Alright, now, there are couple of phrases here that you used back in geometry as well. Angle of elevation, angle of depression. The angle formed by from a horizontal going up, that is called your angle of elevation. So from a horizontal looking up, that angle is considered an angle of elevation. The angle of depression is the angle formed from a horizontal going down. So when you look down at something, that angle is your angle of depression. It's always from a horizontal going up or going down. So look at the application problem here. The kite has 80 meters of string let out and forms an angle of elevation of 52 degrees. If there is no sag in the line, how high is the kite above the ground? So if you'll just draw a picture with this, you got a kite right here. There's 80 meters of string. That would represent this side of that triangle. There's a 52-degree angle of elevation. That's from horizontal going up. So that would be this angle right here. It's 52 degrees. Question is, how high is the kite above the ground? That is this side right here. So which trig function? Opposite and hypotenuse. That is sine. So you have sine of 52 equals x over 80. So x equals, multiply this to the other side, 80 times the sine of 52. And this comes out to be approximately 63 meters. Alright, next problem here, and this will be the last one for today. Katie is in a helicopter 450 feet above the ground. So let's just draw a nice fancy helicopter. Right here. The helicopter is 450 feet above the ground, so that's this measurement. She sees her house at an angle of depression of 16 degrees. Okay. So her house is over here. The angle of depression is 16 degrees. Remember, the angle of depression goes from a horizontal looking down. So there is the horizontal. The 16 degrees would be located right here. Now, if this angle is 16 degrees, the angle in the triangle here would be 90 minus that angle, which would be 74 degrees. And the question is, what is the horizontal distance to her house? That's right here. And so we can write our trig function. This is opposite and adjacent. That is going to give us tangent of 74 degrees equals x over 450. So x equals 450 times the tangent of 74, which comes out to be 1,569.3 feet. Now, one of the other things to remember from geometry is that this angle of depression and this angle right here, which is called your angle of elevation, notice that these two angles form what are called alternate interior angles. This is a horizontal, this is a horizontal. When those two lines are parallel, alternate interior angles are congruent, which means this angle would also form a 16-degree angle. So you could just as well call this angle 16 and use this to find the length of x as well.